Hey, so we'll solve this problem as shown in this picture here. This is a complex programming problem which I'll try to solve to some estimation here. Um, the problem here is that there are set of conveyor belts arranged vertically one above another. So for each conveyor belt, the height of the conveyor belt where it's located is given in terms of y, which is the h here, and the conveyor starting coordinate in terms of x value and the ending coordinate in terms of another x value is provided. So these are the inputs that are provided, where a is the array of starting coordinates for each conveyor belt, and b is the array of the ending coordinates for each conveyor belt, and h is the height, which is nothing but y value for each conveyor belt, and n is the number of conveyor belts. So the problem here is that a package can be dropped from 0 to 1 million points on this x coordinate at any place with equal probability. So that means probability of 1 out of million where the package can be dropped, and package is always dropped at the highest point, so it should cover all the conveyor belts, right? So the thing is, each conveyor belt can go in both directions. It can go either towards right, like, or to the left. So each of the conveyor belt can either go right or left randomly, but you have a choice to fix one conveyor belt's direction to either right or left, and remaining conveyor belts will always go either right or left with a 0.5 probability. So in this scenario, now if you are dropping packages of 1 out of million probability for at every point on this 1 million points, which conveyor belt should you fix the direction on while others rotate either left or right randomly, so that the horizontal distance, the total horizontal distance traveled by this package is minimized until it hits this ground. So in this particular case, for example, the package drops here and travels horizontal distance of the belt 2, then falls onto the belt 3, travels the horizontal distance of 3 and falls to ground. So how would you approach this kind of problem? It's a very tricky problem. Just thinking of this problem and reading this problem itself takes time. And think of this now, each of these belts can go either right or left, and each of these belts, part of this belt is covered by the other belt, and some belts may be completely open like these belts to the upper world. So what should we do to solve this problem? So there are 3 steps you can take. uh, so first is we represent each belt, right? So that is usually in any programming language, you take these inputs and represent it in a nice object representing a belt. So that is the first thing, which is basically a data structure representation, encapsulation of a belt information. So that representation will have a belt starting, which is this, and belt ending x, and belt height, right? So now you'll have an array of belts. The next thing is you need to calculate how much portion of each belt is open to the top directly. So if a package is dropped from top here, how much of each of this belt is open, so that you can calculate the probability that the package falls on this belt, right? So in this case, the entire belt is open, so the probability of the package falling on this belt is basically the length of this belt divided by the 1 million points. So in this case, the length of the belt is 8,000 minus 2,000, which is 6,000, this belt. So 6,000 out of 1 million. But in this belt, it's covered by this upper belt, right? So only this portion, which is 8,000 to 9,000, is open to the upper world. So which is 1,000. So in this particular probability, it's only 1,000 out of million compared to here, right? So like that you need to calculate probability of each of these belts. That is the next task you need to do. But for that, of course, you need to know what is the portion that is visible to the upper world. Third is you need to, this order of the belts that is given here, the heights could be a different order than the increasing order. So the best thing is you first sort the belts in the order of the height, in the decreasing order of the height. So you have highest belt first, second highest, like that, and then you start you start attaching the childs to each belt. So in this, child is nothing but when the package falls from the left of this belt, what is the next belt it falls onto. So that is a left child. When it falls on here, what is the next belt it falls to, that is a right child, right? So you create a tree structure now for every belt. What is the left child? In this case, the left child is this belt. In this case, the right child is this belt, whereas the left child is this belt. Whereas here there is no child because the package directly falls onto the ground, right? In this case, there is no child again. So like that you need to compute the childs of each. You create a tree structure. Now once you do that, you have a data structure. So once you have the data structure, then you start basically computing the times. For that you need to iterate through every belt, fix one of that particular belt direction to the right or left, and then use the probability to calculate probability for each belt, like what the probability that you have for each belt and what is the area. So using the lead, then you compute the travel distance for each belt. So if this belt was fixed to go right, then the travel distance of this is nothing but the average of this belt's length plus the average of this belt's length in both directions, because this belt can travel in any direction with 0.5 probability. So multiply 0.5 times average distance of this belt in both directions, and that's it. So if it is going left, then average distance of this time plus the average distance of this belt in both directions times 0.5, you do that, right? So like that you compute, then you get the overall time, approximate time. So in this particular, so this is the program I have written. So as I said, you basically use these values and sort the conveyors based on the height, compute the probability, then compute the tree structure showing what is the left and right conveyor belts, then iteratively go through each belt, fix the one particular belt and calculate the distance for all the conveyor belts, then fix the next belt, then iterate again all through all the belts to compute the distance. So take the minimum of those distances, then you get that thing. So let's see, here I have encapsulated the conveyor. So you given the height left and right, you create a conveyor object. This is very straightforward, right? You don't need explanation. And here I have the non-overlap parts is to compute the parts which are not being overlapped with any other conveyor belt on top of it. And what is the probability? And then what is the left conveyor belt that it falls onto, right conveyor belt it falls onto. So this is the distance when it falls to the left side of from this conveyor belt, what will be the distance downstream. If it falls from the right of this conveyor belt, what is the total horizontal distance that travels downstream. And this is the overall average distance that the package will travel if it falls on this particular belt. So if you look at this, this is nothing but the difference between these two, right x minus plus this left distance and the right distance with some probability 0.5 and 0.5 of this, then you get this belt distance. So but first is you need to compute the part of the belt that is not overlapping with anything. So here is something that I have written. There may be a much optimal way to do this. So took like 1 million Boolean points. Now go through each conveyor belt. So if then basically fill this Boolean points with 1 or 0, right? So if the conveyor, if this particular portion of the Boolean point is not filled by any other previous container, then you know that that particular portion is not overlapped by any container for this conveyor belt, right? So that is how compute the non-overlapping parts and create an array of non-overlapping parts. Then next is compute the probabilities for each belt. So you just take sum of all the non-overlapping parts, then divided 1 million, you get a probability of the belt, the package falling from on the belt directly if it drops from top. Then you compute the tree of belts, which is left and right child for each belt. So go through each of these conveyor belts, find out basically, but go through then go from the other belts and see if the left range is within the range and right is. It's a very simple operation there, right? So you set the conveyor belts to the left or right depending on where it falls. Once you do that, then you have this loop where you basically go through every belt, fix that one particular belt to the left, and then compute the total distance. Then you fix the same belt to the right, compute the total distance, pick up the minimum distance of this total distance, then go to the next belt, fix it to the left first, then right, then minimum distance of the previous minimum distance. So you iterate like that. But how do you calculate the distance itself? So you need to get the total distances, right? That's where the challenging thing. So once you have the tree, you fix that one of the particular belt, you can use this method to compute the travel distances for each belt. So once you fix the belt, go from the reverse of order, because we sorted in the decreasing order of the heights, but to compute the distance you go in the increasing order of the height. So start with the lowest belt first, compute the distance, left and right distance, then compute the overall belt distance of that belt. Then go to the next belt upper in the hierarchy, compute the belt distance of that based on if it has a right belt that is falling onto or the left belt that is falling onto, right? So for each of this distance you take the probability as 0.5 for the right and left, because other belts could do randomly at the 0.5 probability. Either it can go left or right at probability. But if it is fixed, then we always take probability 1. We know that that particular belt is fixed in one direction. So once you compute that, you compute the total distance by just adding up all that, with multiplying the belt distance with the probability of each of the belt. The probability of the belt is nothing but how much part of the belt is exposed to the package falling onto it directly. So you get the total distance. That's what we call here, and we use that. Okay, so that's all about it. Thank you. Bye.